Ladies and gentlemen, boys and girls, programmers, JavaScript, PHP, Ruby, I don't know, I don't care. Welcome to the Daily Code. It's been a while, and if this is your first time here, I must apologize because maybe the name Daily Code is a bit misleading. This is the first day I've done it in a long time. And maybe it's good that I explain what the Daily Code actually is. So, a while ago, I started streaming doing PHP and JavaScript, and it was fun. A while ago, I say like December 2015, and it was fun, but it was a lot of work, and I had to wind it down towards the end of the year so that I could catch up on all sorts of other stuff that I was doing. And so I did 20 daily shows, and then I wound down, and I've got some free time now, so I thought I would try and do another one. Now, the format is simple. By the way, you look great today. The format is simple. I basically bash my head against a wall of code in 20-minute segments and do it for about an hour, and then I go away. And hopefully at the end of that, I've learned something, and maybe you've learned something, or you've at least had fun watching me flounder around hopelessly for an hour. And I don't know, I just get to learn, which is cool. So thank you for being here. If anyone's here, I can't actually see at the moment. And please feel free to ask questions and make suggestions in chat. You may also have noticed that the code on that slide is PHP, and that's because my day job is as a PHP developer for a company called Silverstripe. So mostly I write PHP code, but I love writing JavaScript code as well. And so the theme of tonight is writing a cross-compiler script, or bits thereof, to convert stuff from one language to another in JavaScript. Now, I've done some code of this before in PHP. I wrote a little blog series on doing this, and it was using the language PHP and basically cross-compiling from one language, just one made-up grammar, to another. So I took something very simple, like 5 plus 7, just doing numeric calculations, and spoke through the process of splitting it out into tokens and arranging it into an AST and compiling it then to a target language. And I'm kind of going to use this as a basis for what I do today, because this is the concepts are quite portable over different languages. It's basically just using string manipulation and regular expression matching and arrays, which is cool. So I'm going to do that. By the way, I'm also trialing some green screening stuff, and I'm trialing some chat stuff. So if it doesn't work well, it may change. Who knows? Let's see. Now, I only have this tab open, and the editor I'm going to use is JSBin because I haven't used it enough, and I think it's awesome, and I really want to try it out. So I'm keen to do that. Let me just get the... I need to get a separate chat window up. Hold on a second. Because I can't see what's going on. Twitch.tv. assertchris chat. There we go. That should be it. I basically just want to see if anyone's asking questions or anything, so that's what this is for. Not that. Make that a bit smaller. Okay, great. I think that's all I need. Okay, so how do we get started with this? Well, I kind of want to use the same grammar that I've chosen before, and you must forgive me because I'm going to be pretty rusty with doing this, but I kind of want to use the same grammar I had before, which was just doing a simple numeric calculation. So if I have a look back through here, I spoke a little bit about what this might look like in terms of pseudocode. So if you use something like, if you used a parser, expression, grammar, compiler, generator, which sounds like lots of words, but actually it does mean a thing, then you may have seen something like this, where you have definitions for expressions in your language. And so we can say something like, this definition is just a regular type of integer, or it's a type of integer and another expression. And then you start chaining kinds of expressions that your language supports, like this. Also, I've just realized that I need to probably tweet about this. Super prepared. Hold on a second while I tweet about this. Alright, cool. Okay, great, I'm back. So you create your language with these expressions, and you'll have expressions that just refer to other expressions and kind of keywords that you can set up, like int. And that's a really efficient way to build these, but actually it doesn't show you the underlying stuff. There's a lot of really interesting stuff, and it can seem really complex because you don't actually get to build your compiler or your cross compiler. You just get to learn the DSL of the compiler generator, and then the compiler generator generates a compiler. So it's very efficient from that point of view, and if you really know the DSL well, then you can do a lot of stuff really quickly. But when I started learning about this, I got really interested in what the compilers were doing behind the scenes, and I wanted to build on that. I wanted to try something, try and make my own compiler and figure out the difficult bits and try and get it there. So this is great as a way of imagining how you compile how you construct a compiler for a language using some parser expression grammar. But what I want to do is I want to build a language from the ground up. I want to build the compiler from the ground up. So, so we're going to try and get like more advanced syntax here. Here I'm just talking about being able to nest expressions. So if you have a look over here, we say that that this expression can be an integer, or it can be an integer plus another expression. And so this will give you rules to say, well, it's an expression which is that integer, or an integer plus an expression, or integer plus expression. And this is the kind of way that you can do recursive expressions within your language or your compiler. We can do other kinds of expressions like this, and so an expression would then become, well, maybe it's an expression plus an expression, or an expression times an expression, or an integer in brackets. And so this we can start doing precedence. We can say, okay, well, maybe it's an integer within here, or it's a multiplication within brackets as this expression. We can start defining more complex interactions of expressions, which is cool. So this kind of logic gives us this, which is pretty cool. There's some bits about grammar. If you want, there's no real sense putting this in chat, but if you want, you can just check out this URL of it. And there's, the click through to different ones. Now, let's see. Then I went on to doing some token stuff. So this is the kind of code that we write, like every day, whether it's in JavaScript, whether it's in PHP. It's very blue. Whether this is in JavaScript or whether it's in PHP, this is very similar to code we write. Often we have conditionals, and within that we have some kind of other thing that our application is doing or that our script is doing, and we can exit and all this kind of stuff. And to us, this looks okay because we've got new lines and we've got tabs, and that makes it readable to us. But machines just see it like this. In fact, these are optional, and it's just a big old mess. Machines just see it like that, and they're able to parse it because they're not trying to. They're not like us. They haven't memorized this kind of structure and aren't trying to determine the structure based on the code they see. They're just going from character to character to character and building up a map of what this code is supposed to say based on the characters they see in a sequence. And we can imitate this behavior. In other words, we can get the machines to understand the code that we want to write by analyzing each bit in turn. Now we don't have to go by character by character by character. We can match greater patterns. So we can say, okay, well, my language to begin with has a plus, and it has numbers, and it has white space. So this can begin to split our source code up into significant portions, and then we can arrange them in some kind of hierarchy so that it's easy to understand what the actual source code is supposed to be on the other end. Now, we'll construct an empty array of what the significant portions of source code are, and then we'll search through each of these things. I've got to go to here. This is very cute. So this is kind of recursive. I'm not really sure what the JavaScript equivalent of using this goto is, but it was quite a cute way of being able to just jump back. So yeah, so this will search through each of the patterns and match the remaining source code to what's there. If there are matches found, it'll add that significant token, and then it will slice the source code smaller, which basically means that the patterns that we match need to whittle the source code string down to nothing, or this will be an infinite loop. We can have some kind of I guess check on that to make sure that it isn't an infinite loop, or if we don't match a pattern and we have stuff at the end, we just throw an exception to say unrecognized stuff. And then putting it all together, it kind of looks like this class. Now I'm really interested in writing this stuff out in JavaScript, and that's kind of what I plan to do. So to begin with, I'm just going to port this to JavaScript, ES6 classes, and then I'll test a few different expressions. The things that we want to try and match are things like 1 and 3, 1 times 5, oh, I'm going to do something more interesting there, 3 plus 6 times 8, and there must be some kind of operator precedence here. But for the moment, we're not doing the operator precedence stuff yet. That comes with the parser, not so much the lexer. It's an interesting term I probably should have explained before, but the lexer is what splits out the origin source code, the source code, into those significant portions. I've got to do some do not disturb on here. So the lexer is what splits the portions of source code into the original source code into significant portions. And at the moment, we're just going to build the lexer. But this is the kind of thing that we wanted to be able to parse. So maybe we also wanted to be able to do some kind of operator precedence, like if we say this and we say brackets here, it should actually work this out. The lexer should say, okay, well, this is a thing. Oops, let's not do that. It should say, okay, this is a group, and so the result of this should probably be multiplied by the 8 over here. But again, the parser is what's going to do that logic. The lexer is just going to split it up into significant portions. It should be able to handle things like lots of spaces here, because, you know, people could choose to format their stuff like that. Okay, so what does this look like? Let's just make sure that we're in ES6 Babel mode, and let's create the class lexer. Analyze. A bug on my screen. Gross. Okay, so analyze was the function that we wanted here. Yes, analyze with source. Okay, now we also want to define the patterns that we had before, so I'll just copy this out and change the structure to be JavaScript-y. Yeah, in fact, I'll make it a getter, because why not? Okay, so we've got some patterns here. So maybe we could, oh, that's right, this shouldn't actually be like this, because JavaScript. So maybe we could be pulling this from another source. I don't know if this should be a getter or not. I'm going to leave it as a getter for the moment. And just to just as a sanity check, I want to console log source and this patterns. Let's not do that. Let's do let lexer. Hopefully my levels are fine and the mic volume's fine and the clicking and the typing is not too loud. This is a completely new streaming place that I'm from. I'm in a new house, I'm on a new internet connection, this is a new arrangement, so hopefully it doesn't suck too much. I see the reality rift going on over here. Don't worry about it, just to pay no attention to that. Okay, so let's begin just by saying 1 plus 3 and see what this outputs. So when we run this, we have an error, unexpected typecast. Line 9. Is there a way to see line numbers on this? I haven't spent too much time in JSBin, so I'm not sure if I can show line numbers. Doesn't appear to be. 2, 3, 4, 5, 6, 7, 8, 9. Yes. Sorry, it's my PHP playing up. Okay, so the source code 1 plus 3 as we expected, and then there's an object of the patterns that we want to match. So very good. I'll just take these quotes out. I'm a bit of a stickler for like a certain kind of quote. To be honest, I actually just like double quotes for no technical reason. Just like the look of them more than single quotes. It's pretty bizarre, hey? Okay, so we know it's getting the source code. We know it's getting the patterns. That's pretty cool. So what else do we do? We have an empty tokens array, which we will fill up with tokens that we match. We loop through each of the patterns and try and match the rest of the source code with it. Okay, let's just do that for now. So let tokens is an empty array. This pattern's for each. This goes. Oh, for each is not a function. This pattern's okay. So I'm getting confused here between using just numerically indexed arrays and using objects. Probably what I can do is for let key of this patterns like that. Let's just try that out. Error. This patterns. Why is that not a thing? I'm very curious now. That's totally a thing. Key in. Remember, kids, always do let key in. Okay, so this is probably a better way for us to do iteration than using for each on this object. We can do something like this. So first thing I notice is the chat is a bit weird here. Clear. I'll just keep on clearing the console to keep it away from chat. I must find a better thing to do. I must find a better arrangement to have with chat. Anyway, now we need to match each of the significant pieces. So the way that I've got this set up is that you don't need to specify that the pattern starts at the beginning of the string, because we want to match just off the beginning of the string. So that looks like this. Source In fact, let's make a copy of this source because we're going to mutate it. So let modify this source. That matches is modified match new regex. Oh, you can see the PHP is strong with me. This patterns key. Okay, I need to make this a little bit cleaner. I think this will work. This is it's been a long time since I've done anything, well, it's been a long time since I've done anything other than React.js in JavaScript, to be honest. So some of these specifics we might need to play with. Okay, I just want to run it once and see if it returns regex. regexp. Like that. Nothing to repeat. That's interesting. Do I have to do double slash like that? Okay, that's interesting. So no matches, which makes sense because the first thing that we're matching is a plus symbol, and this doesn't start with a plus symbol. If we started here with a plus symbol, we should have a match. We might have a match. Okay, never mind. But if we do have a match, that's when we add something to the tokens. So tokens push. And what was the structure that we added? Let me close this, getting confused with it. So we add to the tokens array the type of the token and the matched string. Okay, I'm gonna change this to type. Okay, let pattern okay, what was that? Push into tokens an object of an array of the type and what it matched. So matches. I'm actually just gonna see what this does. That's very interesting. So now we have to try and find a way to make this. We have to try and find a way to make this go to search thing translate well into JavaScript. So how do we do that? What do we do with that? Amazing search I'm going to do go to for JavaScript. I want to see what people are thinking with structuring code like this. Don't do this at home, kids. What? How is that even a thing? No, I don't want to use a separate script to do this. I just want to figure out an elegant way of doing this without it. So what we need to do is go back to the beginning of this loop. So what we should probably say is something like this. Something like this. With tokens here. Well, do we really want to do that? You see, the thing is, we want to keep running this. This is like how to structure recursion well, is what I'm trying to figure out here. We want to go back here. So what's a really elegant way of doing that? If we put this in a separate function and we keep on passing tokens down and we keep on returning tokens, only if we find a match do we run this again. So maybe what we do is, what does matches give us? I want to get a match happening here. Why won't you give me a match? Match plus. I mean, maybe it's the way that I've done this here. Maybe I don't need that. There we go. Okay, so it's found 1 and 1. Maybe I just need to match the second one here. So, because I think the first is going to be the whole expression match, and the second will be each parenthesized set. Oh, I get so confused seeing this stuff. My green screen's falling over. Well, yeah, I really got to work on that. Wow. Glad I noticed that before it actually fell over. Also, I'm like 7 minutes over the 20-minute slot that I want to do, so I think I'm just going to do 2 30-minute slots and be done with that. So I was saying, I think that matches 0 is the whole string that it matches the regular expression to, and then the numeric indices after that are for each parenthesized match that you do. So this is the only one we need to pass. But I'm thinking what we can do is something like, if matches length is greater than 0, then we know we found a match, and then tokens is this this match tokens, and maybe like less of a string, so so a substring of the original source code. I forget the actual syntax for this. I'm terrible at JavaScript. MDN substring. Is that it, or is it slice? Substring. I get so confused between PHP and JavaScript. It turns out I don't need to. Substring start and length. Not bad. Okay, so tokens and then source. Substring start is the matches 1. Well, matches 1 dot length. So if there are matches, push the token. That's interesting. Push the token, then pass that modify tokens array down to the match method. We also have to put this in match, right? So tokens source. This match an empty array and source. I actually just have to return this. I think I just have to return this. Let's see what else this does. No, I don't just return this, but I'll let that be what that returns, and then console log tokens. With any luck, this isn't an infinite loop. Okay, so match gets the tokens and the source, starts off with no tokens and the source, and then somewhat recursively pushes significant tokens and then returns itself, and should probably return tokens when it's done. That seems right. It seems like it could function. Modified is not defined. Source. Length of null. Really cool. That did it. That did it. It all just came together in the end. Okay, so what we need to return from here is an array of tokens and source. I'm not sure why I returned the source. Oh, I know why I returned the source. So if nothing's found, modified is modified substring. Pass that in there and then return tokens and modified. And that should tell me whether there is anything left at the end. Oh, modified not defined. What are you doing? Some crazy thing just happened. What crazy thing just happened? Oh, okay, so let tokens, let source, and then tokens source. Token source, is that clear? Run. Does that do anything? No. Okay. What this is supposed to do, and I'll fix it in a bit, but what this is supposed to do is we're supposed to match everything as best we can, and if there is source that cannot be matched by this, it should be returned as part of this match. And that's the problem. This is the problem here. I need to figure out how to do this exactly, but basically this should contain source code that is unmatched, and if this is not empty, throw an error because because something was unparsable. So I'll try and work out what that is, but I'm going to take a quick break, so hang around for a bit and I'll put some music on, just like a track, and have fun. I'll see you in like